So once again, good afternoon to everyone. So I hope I am audible. So please let me know, some of you.
Yes, good afternoon.
Okay, thank you. So up to the last class, do you have any doubt, any confusion up to the last class? Seems no. Okay, so in the last class, what we have done basically the instantaneous center method we have covered. Okay, and then the Kennedy's theorem we have discussed, and we have also seen how we can find out or locate the different instantaneous center for different kind of mechanism. Okay, so there the basic one we have already covered. That is the one kind of forward mechanism that we have already covered. There we have seen how the number of total number of instantaneous center can be obtained. Okay, the equation we had, that is n equal to at n whole into n minus 1 divided by 2. So where that n equal to that capital N was the number of instantaneous center, and with small n we actually denoted the number of links. Or you can also use I for denoting the number of instantaneous center, capital or small n for number of links. Whatever you use, just mention it, and that should be okay. Okay, so what are the basic steps that we have already discussed in the last class? So we have seen what are the standard method of finding out or locating the instantaneous centers. We know that for pin join, okay, if two links are joined by hinge or pin, then the instantaneous center for that particular two join, if I have suppose link 1 and link 2, okay, and they are being joined by a pin join. Okay, so in that particular case, the instantaneous center between link 1 and 2 we generally denote by I suffix 1 2. Okay, or the same thing if we are writing like I suffix 2 1, then also it means the same thing. That means it is the instantaneous center between the link 2 and 1. Okay, link 1 and 2, link 2 and 1, both are having the similar meaning here. Okay, so in that case we can use either 1 2 that kind of notation or 2 1 that kind of notation. So both can be used and they are not different, they are the same thing. So these things already we have discussed there. Later on also regarding the location of the instantaneous center for pin join, for slider, okay, slider sliding pair, then for other contacting surfaces, all those things already we have discussed. And you also we have used the Kennedy's theory. Okay, so I hope those things are clear to all of you. If you have still any doubt, you can ask. Otherwise, we'll move ahead with the today's discussion. You can let me know if you have any confusion, or otherwise if you have already understood the things, just let me know. That means you have understood. Then it will be easy for me to move ahead. Okay, seems there is no confusion, all of you have understood the thing. So today we are going to solve some problem. Okay, and for that, as I have already told you, if you should as we are going to use the graphical method, so you must have all those necessary required instruments with you, like the scale, protector, and all. Okay, so those things if you have, okay, take it out and will be you can draw alongside. Okay, so the question is, I am going to, I believe the screen is visible to all of you, right? Okay. So what is the problem statement? We have the problem as in a pin jointed forward mechanism as shown in this particular figure. Okay, the figure that is in the right hand side. So the AB link length, it is given as link ABS 300 millimeter. BC and CD both are same and their length is given as 360 millimeter, and AD is given as 600 millimeter. Then the angle BAD, this angle is given as 60 degree. Okay, and which one is the crank? The crank is given as AB is the crank. Okay, and it is rotating at a uniform velocity of 100 rpm. So what is the question? They are asking to locate all the instantaneous center and from there find the angular velocity of the link BC. Okay, so now sometimes this kind of figures, this right now here in this particular question, the figure is already given alongside. Okay, but sometimes only the statement might be given regarding what is the there, what is there. Okay, and what are the different parameters that you have. and from there you should be able to draw the configuration diagram for the same. Okay, so right now in this case, so as per whatever is the given condition, so what you have to consider, you have to consider a proper scale, and that scale you have to mention. Okay, that means what is, at what ratio, at what scale you are going to draw that particular configuration diagram, and then you are going to draw the configuration diagram for that given mechanism. Right now it's a very easy one, that is the 4-bar mechanism only they are talking about. Okay, so now what are given, so the link lengths are given, and the angle between this particular link AB and AD, that is also given for this particular given instance. So now we are going to draw the configuration diagram. For that we are going to take this particular proper scale, and that scale you have to mention. Okay, so suppose this mass millimeter equal to this centimeter we are drawing, or like that. Okay, take any convenient scale, and then we have to draw the AB is given as 300 mm, BC and CD both are 360 mm, and AD is 600 millimeter. So as per whatever is the scale that you have considered, okay, from there we should be able to draw this particular configuration line. So here what we are showing is this AB is this link which is grounded or fixed. Okay, next, this is the 600 millimeter. So as per your scale, whatever is equivalent to 600 millimeter, that much length you have to draw. Next, AB link. Okay, this is 300 millimeter, and this angle you have to maintain as 60 degree. So 60 degree will be maintained. And next, from there, the other two links are same. Okay, you can then what you can do, you can use your compass, and from here you can draw, suppose you can take 360 millimeter. Okay, and you can draw an arc here. From this at the center you can also draw an arc here, and automatically both of them will be same. Okay, so it will be 360 millimeter or 360 millimeter. Okay, as per your scale. So up to this much, drawing the configuration diagram, I hope it's clear, right? Let me know. Next, what is our main task? Our main task is, we should, for this particular case, we should be able to locate all the instantaneous centers, and by using the instantaneous center method of velocity analysis, we should be able to find the angular velocity of the link BC. Okay, so this link, that is the coupler. Okay, so now for that, what we will do, we know that we have got this particular basic, we already have that particular basic relationship. Okay, so about omega and how it is related with v, that is the linear velocity and angular velocity, and similarly angular velocity from if it is the rpm is given, that is n is given, how we can find out the angular velocity, all those things we already know. Okay, so now as per the question, what is given, the crank AB is rotating at 100 rpm. Okay, so that is n of AB, rpm is given, so n of AB is 100 rpm. Or from there what we can obtain, so n is given, so we can very easily obtain omega of AB. Okay, so how to find it out? N is given, so it is 2 pi n by 60, you already know, so that you can use. So in terms of n, it is 100 rpm, it is given, so 2 pi into 100 by 60, so that is going to give you, the answer is 10.47 radian per second. This is the angular velocity, right? So that is done. Next, see, we know that the point, this point B, whatever is there, okay, that is a point on this particular link AB, right? And we have got the length of this link AB. Okay, so now from here what we can have, so already these lengths are already given. AB length, it is given as 300 millimeter, which is nothing but 0.3 meter. Okay, if I convert it to meter, and from there what I can have, I can utilize the basic formula for finding out the velocity. So right now, as AD, this is a grounded link or fixed link, so with respect to A, whatever is the velocity of B, it will be absolute velocity or relative velocity. AD link is fixed. Okay, and I am talking about right now AB. Okay, with respect to, and we are talking about V of velocity of B with respect to A. So that will be absolute velocity or relative velocity. Who can tell me?
Absolute, sir.
Yes, correct. Okay, So that means I can either write V directly, I can write VB, V suffix B, or I can also write like VBA, that is velocity of B with respect to A, same thing. Okay. And what is the basic relationship that I have? It will be VB equal to omega of AB into AB. Okay, just like V equal to R omega or omega R into AB, right? So now I already have these values. Okay, omega AB just now I have found out. Okay, and AB link length already I have. So just I'm putting these values, and we are going to get the value of VBS 3.14 meter per second. Okay. Next thing, what is our task? Our task is to locate all the instantaneous centers. So if I need to locate all the instantaneous centers, I must know how many instantaneous centers are there for this particular mechanism, right? So now for finding out that, we already have this particular equation. Okay, I or n equal to n whole into n minus 1 divided by 2. Okay, so now it's a, what kind of mechanism is this? It's a 4-bar mechanism. So number of link number of link is how much? N equal to how much? This four links are there. So from there, I can directly put utilize this value, and 4 whole into 4 minus 1 divided by 2. It will give me number of instantaneous centers as 6. There are 6 instantaneous centers. Okay. Up to this much it is okay. Now, if there are 6 instantaneous centers, now what is our task? I know that there are 6 instantaneous centers, so I right now must know what are the different instantaneous centers. Okay, so for that I can draw that particular table. Okay, and suppose link 1, how many links are there? Link 2, link link 3, and link 4. Okay, so for them, what are the different instantaneous centers? We'll write it down. Okay, that table you can make. So here these are the links that we have, and here the ICs, that is the instantaneous centers. Okay, so for link 1, what are the different instantaneous centers that we have? So this is one method. Apart from that, you can also do like this also. Okay, you can make that particular circle, and 4 links. Suppose this is 1, you can get the points. Okay, 1, 2, 3, and 4. Okay, and join them. Okay, so 1, 4, this will be I14 will be 1. Okay, I34 or 43 will be another, I23 another, I12 another. Okay, similarly, I join this and this will be another. Okay, I24 and I13. Okay, so these are the different instantaneous centers, that means. Okay, so for if I look from this particular table, okay, so for link 1, what are the different instantaneous centers that I have? Okay, I have got I suffix 1, 2, that is instantaneous center between 1 and 2. Okay, similarly, I am not writing the I repeatedly because it is writing here is difficult. So I13, then I14. Similarly, for number 2, second column, okay, I have got I23 and I24, right? Similarly, for the third one, okay, I34 that I have. So for this fourth, it will be I43, which is same as I34. Okay. So these are that means the 6 required instantaneous centers. Okay. So the naming we already have. Now, what is our task? Now I should be able to locate it. Okay. Locating the instantaneous centers. Now, for that, once again, we'll move to the whatever is the configuration diagram we already have. Okay, so this is this blue line. Okay, so whatever is the blue diagram that we have. Okay, it represents the configuration diagram. Okay, so this is link 1. Okay, so similarly, we have got link 2, 3, and 4. This is link 2, link 3, and link 4. So these links, okay, so they are joined by what kind of joint is there? It is pin joint or hinge joint. Okay, so now, so this is link 1, 2, 3, and 4. Okay, so now we know that for pin joint or hinge joint, if two links are being joined by pin or hinge, then where is the location of the instantaneous center for this case? Who can tell me? For pin joint or hinge joint, location of instantaneous center. Who will tell me? No one. So for that, the location of instantaneous center is at the pin itself. Okay, at the center of the pin itself. So this is link 1, link 2 joined by this pin. Okay, so I12 will will be here itself. Similarly, I can find out the other permanent type of instantaneous center. In between 2 and 3, this is I23. Okay, so this is the position. Similarly, here also I have got on hinge in between link 3 and 4. So this is I34. Similarly, in between 1 and 4, this is I14. Okay, so 4 numbers of instantaneous centers are being done. Okay, so from here I12 I have obtained. Okay, similarly, apart from I13 and 24, we have obtained all 13 and 24 is not obtained. Other 4 we have located, right? Now what is our task? We have to locate I13 and I24. Okay, so these 4 instantaneous centers are done. Okay, now is there any other way? Okay, that means any other known way to find out that particular instantaneous center or locate the instantaneous center? Right now, no. But now we know that there is one theorem known as the Arnold-Kennedy's theorem, or only Kennedy's theorem, and it states that basically if three bodies they have got plane motion between them, so then the three instantaneous center between them, okay, they lies on the same straight line. Okay, that is what is the logic we are going to utilize. Okay, so Kennedy's theorem we are going to utilize here. So for finding out I13, what I can do for I13, just like yesterday. Okay, so 13. Okay, so it I13 means it's the instantaneous center between link 1 and 3. So 1 and 3 definitely will be there. And now for using the Kennedy's theorem, what is required? We need to have 3 bodies. So I am considering one as link 1, link 2, and link 3. Definitely 1 and 3 has to be considered. So in between these 3, what are the different instantaneous center? Who can tell me? For these 3 links 1, 2, 3, what are the instantaneous centers? There will be first 3 instantaneous centers because n equal to 3. So 3 whole into 2 divided by 2 equal to 3. So I12 will be there. Then I23 or 13 you can consider, no problem. 13 and I23, right? So these 3. Okay. So these are the 3 instantaneous center. And what we know? All these 3 instantaneous center will lie on the same straight line. Okay, as per Kennedy's theorem. Okay, so now let's move ahead. Now I12, it is already, we have already located here. Okay, similarly I13 we need to find out, no problem. And we have I23. So I23 is this one already located. So as per Kennedy's theorem, where I13 will lie, these 3 instantaneous center will lie on the same straight line. Okay, so that means along this particular line somewhere our I13 lies. Okay, right now I don't know where. Okay, but I know along this line. Similarly, I can also consider for I13. So in terms of 1, 2, 3, I can consider these 3 links 1, 4, and 3. Okay, they have got relative position in between them. So in that particular case, what are the instantaneous centers that I have? So I'll have I14. Okay, I have I13, and I have I43 or 34, same thing. Okay, so once again, let's come to this particular figure. So I14. Okay, so this is already located here. Similarly, I13 I need to find out, no problem. I43. So I34 or 40 same thing. So it is already located here. Okay. That means now as per Kennedy's theorem, these three instantaneous centers should lie on the same straight line. Okay. So if I draw a straight line here, so it will move something like this. Okay. Now one of statement says that, okay, as per this statement, okay, I13 will lie along this line. This line. As per the second statement, it will lie along this line. So where both of them are satisfied, so at the intersecting point, that means both of them are satisfied. That means at the intersecting point, I13 lies. Okay, so this is the location of I13. Similarly, we can do the same thing for finding out I24. I can consider I can consider one link, two, two and four definitely has to be considered. Two, one, and four, and I can consider two, 3 and 4. Okay, so from here, if I consider 2, 1 and 4, I will get I21. I am just writing 21. Okay, I24 and I14. Okay, similarly from here I will get I23, I24 and I34. Okay, so now as per Kennedy's theorem, these three should lie on the same straight line and these three should lie on the same straight line. Okay, so let's come to this particular figure. So I21, 21 or 12, it is already there. Okay, this one. Similarly, 24 we need to find out. So 14, I14. So I14 also has been located here. So I24 should lie on this line which is joining these two. Okay, that means on the same straight line. So I am drawing like this. Similarly, from this statement, second one, second consideration, I23 or 23, it is already there. Okay, 24 I have to find out. I34, I34 is already there. So on the line joining these two instantaneous center, I24 should also lie. Okay, so like this. Now, once again, it is the similar case. One statement says that it should lie on this particular line. Another statement says it should lie on this line. So wherever both of them intersect, this is the point of I24. Okay. So now I24, that means I13 and I24 all are located. So come to this particular previous, sorry. Okay, come here and these two are also located. Okay, that means we have located all the instantaneous center. So first thing is done. Up to this much, all of you have understood? Let me know. Please unmute and let me know.
Yes, sir.
Okay, thank you. So next is what? We just have to find out the, by utilizing this particular method, okay, find out the velocity of the link BC. So that is easy. Okay, for doing so, what we can do for angular velocity of BC, what we can utilize. So suppose for finding out the angular velocity of BC, okay, so this point B, it is a point on the link BC. Yes or no? Point B is also a point on the link BC. So from this knowledge, what we can use? So from there, we can write velocity of point B on the link BC. Okay, I can write VB, that is velocity of point B. Okay, just like V equal to R omega. Okay, so from here, omega into I13B, this particular length. Okay, so I13 is already located. Okay, so B point is this. This is the B point. Okay, we know that this velocity is, okay, if we are talking about the instantaneous center, is actually proportional to the distance from it, right? Okay, and now this I13B, so this is this length. Okay, this first length. So this length can be measured, I13B. Okay, this is this length. Okay, it can be measured by using your scale and convert as per whatever is the scale that you have considered. Measure. Okay, measure and convert as per scale. Okay, so if that is done, okay, your task is over. You measure this much length and convert it to as per your scale, and then utilize this formula, just like P equal to R omega. And what you will get by measurement, you have obtained I13 B as 0.5 meter as after conversion, and that value can be directly utilized here. So PB, we already had found out the PB value, okay, in previous case, and that we are utilizing. And right now, after the solving it, so P equal to R omega, that we have done, and we have obtained this value. Okay, so this completes this particular problem. Yes, all of you have understood. Let me know.
Yes, sir.
Okay, thank you. Others? What about others?
Yes, sir. Understood.
Okay, thank you. Next, we'll be solving another one today. Okay, so this is for a slider crank mechanism. Similar is the case. Once you have understood the previous case, this should also be known. But right now, we have got the configuration is different. It's a slider crank mechanism. So locate all the instantaneous center for this slider crank mechanism as shown in this particular figure. The length of crank OB, this is the crank OB. The connecting rod AB, this is the connecting rod AB, are given as 100 millimeter and 400 millimeter respectively. If the crank is rotating clockwise with an angular velocity of 10 radian per second, 10 radian per second, okay, so this is the angular velocity. You have to find the velocity of the slider A and angular velocity of the connecting rod AB. Okay, so these are the two things that you need to find out. Okay, so now for that, once again, sometimes this configuration diagram might be given, sometimes it might not be given in the questions, but from the question, whatever is the given data, from there you should be able to draw this configuration diagram for a slider crank mechanism. Okay, so what we'll do, we are going to first draw the slider crank mechanism configuration diagram. Okay, next the thing is, see OB for this particular length link of OB. Okay, the omega is given, omega of OB is given as 10 radian per second. Okay, and length of this link OB is also given as 100 millimeter, that is 0.1 millimeter. Okay, so from there we can find out the linear velocity of this particular, right? So from there what we can write, so linear velocity of link OB can be written as POB equal to, that itself is nothing but, it is O is a fixed point. Okay, so that it is itself is nothing but PB or PBO, P velocity of B with respect to O. Okay, so that is equal to P equal to R omega, that we already know. So omega of OB or BO into the length, link length OB. Okay, so omega is already given as 10, link length is 0.1 millimeter a meter. Okay, so answer is P of B equal to 1 meter per second. Okay, this is the 1 meter per second. Okay, so that is done. Next thing, we have to locate all the instantaneous center for it. Okay, so now slider crank mechanism, how many links are there? In a slider crank mechanism, how many links are there? There are 4 links, we already know. Correct. Okay, so the fixed link, okay, we have got the crank, we have got the connecting rod, we have got the slider, okay, and the frame or the ultimately frame or the fixed link, the same thing. Okay, so these are the 4 links. So what kind of motion they have? These links have fixed link. Is there any motion in the fixed link or the frame?
No, sir.
Definitely no. Crank, what kind of motion it has got? Crank has got rotational motion. These are the hinge joints. Okay, similarly this slider, what kind of motion it has got with respect to the this particular frame? It has got sliding or reciprocating
It can
motion
slide,
along
sir.
this. Yes, correct. So it slides or reciprocates along the line of stroke direction. This is the line of stroke direction. Okay, and about the other link, if I consider this, it has got the hinge joint point or pin joint here. Okay, so this connecting rod with respect to the slider, it can have the rotational motion. Okay, so that is the thing. Okay, so now that means a slider is involved here. Now four links are there. That means the number of total, there are four links. Okay, so there are the number of instantaneous center will be how much? So once again, n value is 4. So we are going to utilize n whole into n minus 1 divided by 2 equal to the number of instantaneous center. So that comes as 6. Okay, just like the previous cases. Now that means we know there are 6 numbers of instantaneous centers. Now after knowing there are 6 number of instantaneous centers, we must know who are they, what are the name. Okay, so for that we can once again, just like the previous case, we can make that particular table, or we can also draw that particular circle, mark the different links, okay, 4 points, and join them and get the different instantaneous centers. Okay, so for that, what are the instantaneous centers that we will have? So there are 4 links, 1 2 3 and 4 will be numbering like that. Okay, so link 1 is the fixed link, link 2 is link 1. Okay, link 2 is the crank, link third we are considering the connecting rod. Okay, and this slider is link 4. This way we are going to number them. Okay, we must number, then only we'll be able to say properly. So now in between them, so it will be what are the different instantaneous centers. We'll have instantaneous center between 1 and 2, that is I12, I can write I suffix 1 2. So other i's I am not writing, okay, because it is difficult to write here. Okay, similarly we'll have 2 3, we'll have 3 4, we have 1 4, then we'll have 1 3, and we'll have 2 4. Okay, just like in the previous case, you can make by column tabular wise also. Okay, so these are the 6 instantaneous centers we have numbered. Now we know how many are there, we know who are there. Now we must know where are they. Yes, that means we have to locate it. Now for locating, what we are going to do, we are going to draw the, we are going to go for the configuration diagram, right? And the configuration diagram of the slider mechanism we already have. Okay, this is the case, and the link length, link numbers we are going to give. Okay, this is 1, the crank is 2, this is 3, okay, and this is 4. Okay, up to this much, any confusion? Let me know.
No, sir.
Okay, thank you. Now from here we have already seen that there are certain numbers of hinge joints. Okay, so some fixed points are there. Okay, fixed links are also there. So from there the fixed and permanent and instantaneous centers can be directly located by visual inspection. Okay, so this is link 1 and link 2 joined by the pin joint. So directly at this particular center of the pin itself, I12 will lie. Okay, so this is I12. I12. Okay. Similarly, this is 2, link number 2, link number 3, right? So from there, so this is a pin joint, so I23 will lie. Okay. Similarly here at this, once again we have got a pin joint here. Okay, so this is link 3 and slider is link 4. In between them, I34 will be there. Okay, so these 3 are done. That means yes, I12 done, I23 it is done, and I34 it is done. Okay, these are done. There are another 3 that is remaining, right? Now if I consider this slider and the slider number 4, okay, that is the link number 4, and the fixed link, that is 1. Okay, with respect to the frame, what kind of motion the slider has got? It it has got sliding motion along the line of stroke direction. That means line of stroke direction is this much. Okay, that means if this is A, slider is denoted by A. Okay, then V of A will be in this particular direction. This is V of A, the direction of VA, right? Now this slider is link 4, fixed link is order frame is link 1. Okay, that is it's a sliding pair. Okay, 1 and 4 constitute a sliding pair. So for sliding pair, from our previous knowledge, we know that instantaneous center lies at infinity. So from here we are drawing with dotted line and perpendicular to the line of stroke direction. So line of stroke direction is this one, perpendicular to it. So I14 will lie at infinity. So we'll draw with cursor. Okay, so that is the I14 at infinity. We have to write I14 at infinity. Okay, that is I14 also is located. 4 numbers of instantaneous centers are being located. Done. Next, what is remaining? We have got I13 and I24 unaccounted for. Okay, so for that there are no other logic. Now we are going to go for the Kennedy's theorem. So Kennedy's theorem, what does it say? Basically, if 3 bodies have got relative plane motion in between them, then the 3 instantaneous center between them, okay, they lies on the same straight line. Okay, so for that is what is remaining. I13 is remaining, right? So for I13 we are going to utilize the Kennedy's theorem. Okay, yes, up to this much it is okay. Let me know.
Yes, sir.
Okay.
Sir.
Yes. Yes. Someone is asking the question, or yes sir, you are saying yes sir. Okay, so whatever. So for I13, 3 bodies we have to consider. Let's first consider link 1, 2 and 3. Definitely 1 and 3 I have to consider. Okay, and for these 3 links, what are the different instantaneous centers? This will be I12, okay, I13 and I23. Okay, so now I12, it is already here, and similarly I23 also is located. Okay, I12 is here, I23 is here. So now on the line joining them, I13 should also. Okay, so now I am drawing that particular line. Okay, drawing this particular line joining the other 2 instantaneous centers. That means on this particular line, actually I13 should lie. Similarly, if I now consider link 1, 4 and 3. Okay, 3 we must have 3 links, okay, for using the Kennedy's theorem. So for these 3 links, what are the different instantaneous center? I14, I13 and I43. Okay, now I43 or 34, that is already located here. Similarly, we have got I14 at infinity along this particular line. Okay, yes, along this line. So if I join them, so along this line, okay, that means now I13 should lie on this particular line. Okay, joining these 2. Similarly, as per another previous logic, it should remain in this particular line. So that means wherever they intersect, there we have got I13. Done? Understood? I13 is also is located. Yes, up to this much, I hope all of you have understood. Similarly, we have I24 that is remaining. I24 is remaining. For that also, we are going to use the Kennedy's theorem. Okay, so I hope all of you will be able to utilize the Kennedy's theorem here for I24. I24 means the instantaneous center between link 2 and 4. Definitely that means link 2 and link 4 has to be considered. Apart from these 2 links, another link has to be considered. Okay, let's consider first 2, 1 and 4. Then I will be having I21, I24 and I14 as the 3 instantaneous centers. Out of them, I21 is already located, okay, or 12, 21 same thing, okay. I14 also we have. I14 is at infinity, okay. So for that, what I will do, okay, this link, okay, which is this line which is showing the infinite length, okay. So as it is infinity, I can shift to this much also, okay. If an infinite length, I shift by a very small definite length, okay, it will be kind of parallel only, okay. So here also that means same thing. I14 at infinity, here also I can consider, because it is infinite length and the other lengths are very finite, okay. So now these three instantaneous centers should lie on the same straight line. Similarly, I can consider I2, 3, and 4. Okay. So in that case, I have to go for I2, 3. 2, 3 is already here. I2, 4. Okay. 2, 4 I need to find out. And I3, 4. I3, 4 is here. Okay. So I can draw this particular line. That means on this particular line, on the extension of it, I2, 4 also will remain. In the previous case, it will remain here. In this case, it will remain here. So wherever they intersect, we will have I2, 4. Okay. That means I2, 4 also is done. So all the 6 instantaneous centers we have covered. Okay. Understood? Let me know. The logics all of you have understood how we have,
Yes, sir.
okay, how we have utilized the Kennedy's theorem, right? If you have any doubt, anyone else, okay, others, we can clarify. Seems no. Okay. So now that means we have already located all the instantaneous centers. Now we have already almost there. Okay. And so we can directly utilize this, find out those lengths of this particular instantaneous center from a particular point on the from the mechanism. Okay. And those lengths can be measured and converted as per the scale, and those values can be utilized later. Okay. So now we already know the ratios. Now see, if I measure, then the I13A, that particular length has come as 0.46 meter. Similarly, I13B by measurement has come as 0.56 meter. That is by measurement. Okay, you can directly utilize the scale and find out how much centimeter you have obtained and convert as per the scale that you have considered previously while drawing the configuration diagram. Okay. Now, up to this much, I believe it should be clear. Now, we have to find out the velocity of slider A. Now, velocity of slider A means PA. Now, what I can write from this particular method, that is the instantaneous center method of velocity analysis. Okay, so PA by that I13A. I13, that is this instantaneous center, is associated with point A. Okay, if you look at, so this was the A. Okay, slider was given as A. Okay, and this I13 is directly associated with this particular slide. Okay, so this length is I13A. Okay, this length we have measured. Okay, similarly, which one we have measured? So this is the point P. Okay, that is, this is the point P that we have. Okay, and as per our knowledge, so velocity of PB will lie in a direction perpendicular to it. Okay, that is the PB direction, perpendicular to this particular link. That is OB link. Sorry. Okay, so now what we can write? So this ratio will be same, PB by I13A equal to PB by I13B. Okay, this length will be same. I13A and I13B, it is already here. So found out from our previous knowledge, PB also we have found out. Okay, because PB already we have found that as how much? We have obtained PB as 1 meter per second. Okay, so what is unknown? VA is unknown. So that out of these four parameters, three are already known. Okay, so only unknown is VA. So if you just solve it, okay, you are going to find out VA value, that is 0.82 meter. Similarly, we know that V equal to R omega, that thing we already know. Okay, so now if you consider any of this particular question, okay, so basically V A and B. Okay, so this link is, this is nothing but this AB, right? Okay, A point is here, B point is here on this link AB. Okay, now what I can write, omega of AB, that is V equal to R omega, that we already know. Yes, so omega equal to V by A, right? So if I consider suppose this link, okay, so this is just like omega, right? This ratio is just like omega. It is length, okay, I31 is length, okay, it is like V equal to R omega. Okay, so omega AB is nothing but I can write either VA by this particular I13A, this length, okay, V equal to R omega, or if I consider that particular AB link, okay, I can also write like omega AB equal to the same, that is V of B I13B. Okay, so take any one of the ratio and put this particular value, because right now we know VA also, we know VB also, and the other two lengths already have measured and found out. Okay, so if you put those particular values and by using those known values, you will find out omega AB equal to 1.78 radian per second. Okay, and this completes this particular problem. Now let me know whether you have understood or not. Okay, with this basically today's class we have covered. Okay, let me know whether you have understood or not. If you have any doubt, you can ask. I hope all of you have understood.
Yes, sir.
Okay, thank you. So then this much for today. So in the next class, we'll be discussing about the acceleration analysis. So in the meantime, you practice some of these kind of questions. Okay, this kind of. If you don't draw and don't locate by yourself, then you may find difficulty later on. Okay, but if you try, these are easy things. Okay, just the logics, proper logics, you should be able to utilize. Okay, so with this, basically, you have completed today's class. So let me take the attendance. I'll be calling your name. You just respond to your name. Samim,
Present, sir.
it is sir. Vishwajit,
Present, sir.
Catherine,
Yes, sir.
Tapas,
Present, sir.
Jigyas,
Present, sir.
Shubham,
Present, sir.
Andreas, Ashish,
Present, sir.
Khandip, Khandip is I think no. Vishal,
Yes, sir.
Semphang,
Present, sir.
Albek Sina,
Present, sir.
Jodian,
Present, sir.
Swain Singh Dao,
Present, sir.
Mario, Nurangsi,
Present, sir.
and Joydeep.
Yes, sir.
Okay.
Are you present, sir?
Okay. Are you present? Okay.
Are
One, two, three. Yes. Okay. Okay. Thank you, everyone.
Okay.
So we'll meet in the next class.
Thank you, sir.
Sir, thank